I'm Anthony LeBude from NC State University and the project director on the labor automation, labor efficiency, automation, and production LEAP nursery crops toward sustainability, which is a USDA NEFA specialty crops research initiative grant for ornamental crops looking at automation and nursery production. And part of that is making folks aware of our outputs and efforts. And today we have a guest speaker that is going to talk about some automation in specialty crops that is going to help us learn how automation is used in other sort of adjacent crops. I can find my screen. So this is the project management plan, talking about all of our objectives and our outputs, which are going to be 4 pieces of automation, but additionally, we are going to try to stimulate adoption of existing automation or translate automation from other specialty crops into nursery crops. So this presentation today functions as a way of making nursery crop producers aware of automation that's available sort of in adjacent areas. So with that, I will first of all say thank you for attending. We really appreciate it for your time, especially in the spring. And I'm going to turn it over to Amy. I'm going to stop sharing so she can introduce our special guests today. Thank you, Amy.
Yeah, thank you. Before I share Kaan's distinguished career, I wanted to share what I thought might be one of his most pivotal findings, especially for the growers that have joined us today. So by converting an vineyard to an automated no-touch vineyard, he reduced the cost to manage each vine from $1 per vine to 7 cents. So I hope I have your attention on the edge of your seat, waiting to hear what else Kaan has to share with us. So Kaan Kurtural is a distinguished figure in viticulture. He's worked in vineyards basically since he could walk, followed his father around the vineyard, learning about soils, about grapes, and about irrigation. And he has continued to follow in his father's footsteps, professionally beginning his career at the University of Kentucky, which is where I met Kaan. From there, he took a position at California State University in Fresno, where he served as the Bronco Wine Company Viticulture Chair. In 2015, he accepted a position as an extension specialist at UC Davis, where he managed the Oakville Viticulture Laboratory. This included an 18-acre research vineyard near Napa Valley. And he spearheaded innovative research on climate change impacts, mechanization, and sustainable viticulture practices. There's really nothing about grapes that Kaan has not studied and does not know backwards and forwards, truly. And this is where he developed the no-touch vineyard system. He redeveloped the research and teaching vineyards there at Oakville, as well as modernized the laboratory and administration facilities. He's published over 100 journal articles and led the viticulture group, which included 14 farm advisors within the UC Cooperative Extension Service system. He's also taught numerous viticulture courses and was a frequent keynote speaker in international symposia such as the Terroir Congress. In 2022, Kaan made the transition from academia to starting Kurtural Family Vineyards and Kurtural Vineyard Consulting. He continues this research and development through his vineyard, Slayback Vineyard, constantly developing new technologies to ultimately bring the most distinguished and sublime wines to market. He does the majority of vineyard management. At Kurtural Vineyard Consulting, Kaan and his team perform contract services on applied research, mechanization, and consult on a range of topics, including irrigation and canopy sensing and mapping. I'm really pleased to have Kaan join us today. 2 big areas of overlap between vineyard and nursery management are irrigation and pruning. And by the way, the majority of that $1 per vine was pruning. So without any further delay, Kaan, the floor is yours, so to speak.
All right. Thank you, Amy. Let me get my screen. Okay. Well, thank you for inviting me. There's life after academia. I was in it for about 22 years, but overhead was just too high, getting to be too high. So I chose freedom. Anywho, not to influence anyone. So Amy asked me to talk about some of these developments in mechanization and automation in wine grape vineyards. Of course, there's some typical characteristics of vineyards. They're quite different than what you might see on TV or in movies. It's just like any other crop, for lack of a better term. So majority of the vineyards that we deal with are irrigated, and majority of these irrigated vineyards are micro irrigated, meaning that there's a drip hose and there's a emitter, so on and so forth. But all these vineyards are dependent on hand labor. So automation and mechanization doesn't get rid of it. It just reduces it. And a majority of our vineyards are owned by families. We don't have any industrial farms, meaning that none of these like 1,000-acre farms, using glyphosate, etc., that you might see on these so-called documentaries. These don't really exist. However, we have some costs other than hand labor, which is transportation cost to markets. And majority of these labor operations costs are in-season practices, meaning that these will happen after the crop is removed, and about 80% of those costs are going to be your pruning costs. But with like everything, it's a traditional industry, as they call it, and change can be very slow. So the first circular that came out of University of California for drip irrigation was released in 1994. So, I mean, drip irrigation was first published in ASHS journals in 1972, I think. So it can be that slow in grapes. However, there are some factors that has driven this. Number one is timeliness of cultural practices. Average vineyard size is about 100 hectares, 100 and it's quite large. And what we have is a willing labor force. This is like lacking, and cost of labor today. We have a vineyard ourselves. If I were to hand prune this with the overhead I pay, like FICA, etc., it's coming up to about like $32 an hour to me. And of course, there's quality of life and socioeconomic factors that affect this, lack of a willing labor force. People don't want to work in vineyards. It's, not easy work. And all this rhetoric about like, jobs for Americans, etc. When we did our surveys back in the early 2000s, we found out that, majority of the American labor force was not fit to work in agriculture, meaning that, they were not in shape to be able to do this work. And since, there's these quality of life and socioeconomic factors, proximity to population centers, this is somewhat 100% dependent on migrant labor previously. There's a lot of foreign competition. This has, come into a foray again with the tariffs, etc. recently. And then there's land availability and cost. For these businesses to survive, there was no other chance other than mechanizing these vineyards in California. So what can you do in vineyards mechanically? So we have three commodities. We have wine grapes, raisin grapes, as well as table grapes. Harvesting has been done by a machine since the late 1960s. So 90% of the wine grape acreage is harvested by hand. Pruning, about 65% of it is going to be pruned ahead of final pruning by a machine. A lot of the canopy management is done mechanically, such as leaf removal and hedging. Crop load management is not done because people are paid by the tons they grow. So I'm going to mainly talk about dormer pruning, shoot removal, berry and cluster thinning in vineyards. And these are the decisions people take, and these are the things that cost a tremendous amount of money for the grower. So we published a review in 2020. These are the checklists designed for vineyard properties for successful vineyard mechanization. You just cannot take any old, 100-year-old vineyard and say like, I'm going to mechanize this. It just doesn't quite work that way. You either start from scratch, plant it in this manner, or you try to adapt these vineyards in this manner. The main thing is, making sure that you have the correct, row spacing, vineyard spacing, and the trellis and training system that will take care of, majority of adaptability of these vineyards to mechanization. Rest of the stuff, the grower will have to decide on what market they're chasing, whether it's a bulk market or a boutique market. They can be amended as the vineyard grows. And I should point out that there has been a rapid shift in trellises in California and also in the rest of the world, for lack of a better term. If you look at movies, pictures, etc., what you see in our marketing materials, you'll see this what they call the vertically shoot position types, and these are these short trellises that you see. They look very nice, etc. These have been all abandoned in the major production areas of California due to incompatibility. First of all, with the change in climate, and also, of course, with mechanization. And if you travel to other regions in the world, like Southern Europe, etc., you'll also see these VSP types depicted in either inset A or inset F. That have been pruned by leaving long canes. This is not mechanizable. This is not mechanizable at all. So this also has been abandoned. So we don't use them in California. So majority of the vineyards, new vineyards, greater than 70% of them are going to look like a inset E or this tall trellis you see in the foreground in this picture. So this was a very popular paper we published in 2022 before I left the university, and it has really had a a large impact on how vineyards are developed and how this mechanization can take space. Anyways, of course, there's adaptability of these types to mechanization. These are the practices that has to be done in a vineyard: pre-pruning, final pruning, shoot removal, leaf removal, crop adjustment, trunk suckering, and harvest. So in a given acre, each pass, adds about like 8 hours of burden. So that's going to take about like 8 people working in an hour in an acre to like do any of these practices. But when we did all this work back in the early 2000s, from California sprawl to a vertically shoot position to quadrilateral systems, etc., there was only one trellis type that was adaptable to all these practices that can be done by a machine. So we can do all these practices by a machine, and I have some videos that I'm going to show you how these work. It's not just a single machine; it's a frame that you hang different machines that can do these practices. So these are some of the dimensions that we work with in all these, such as single high wire and quadrilateral trellises. Of course, we use a lot of steel in these systems. Single high wire and quad are the commonly used systems now. The quadrilateral systems are essentially 2 single high wire systems separated by about 1 meter within the row. So you're actually growing 2 vines within the same space with a little bit of higher yield. But this one is essentially abandoned in warm climates. So these trellis systems, the single high wire system is 150 to 170 centimeter tall. It's a single canopy. It's non-shoot positioned. It has about a 35% exposed leaf area, and you can get into production in about 18 months. Yields, of course, depending on a cultivar, you're looking at 22 to 40 tons to the hectare. Everybody gets paid by the yield. So the goal is to optimize yields per given square feet or per acre. High quad systems are taller. This is a divided canopy. This is also non-shoot position, has greater exposed leaf area. Again, a similar precocity, 18 months to production, 25 to 52 tons to the hectare. So these are all productive systems. And this is how they look. This is the single high wire system. This is the no-touch vineyard that served as the model at University of California. It's essentially a single vine trained to a stake, and these stakes are engineered. They're beveled so that when the wind hits it, the wind deflects off of it, because some of these rows can be as long as 2 miles, so you don't want them to act as sails. It's a very simple system, and the high quadrilateral system is essentially the same system, but separated by about a meter. So you're essentially growing 2 vines given in the same space if you want more yield in this case. Dormant pruning and mechanical systems. None of this is new. However, it has improved tremendously since the 1980s when people started doing it in California and Australia. These systems, you need to be able to move through these vineyards quickly, because our average size is about 100 hectares. When does this start? Well, it depends on where you are. If you're farming in the high desert, like in Southern California by the grapevine, or if you're in Eastern Washington, you're probably going to start in like November or December. So it's a dormant season practice, but incidence of rain will hold these people back, because you're moving a lot of iron through the vineyards. The severity of pruning will define the bearing surface. And the capacity of how much fruit you can hold on these things. So what I mean by severity, how tall you want to grow. Let me see where my thing is. How tall you want this bearing surface to be. So in this case, these were pruned to 2.5 inches. So this is going to be a medium yielding vineyard in this case. Or you can prune them all the way up to 6 inches tall and go to town. So mechanical pruning, of course, that was a single plane canopy. This can also be done in a quad vineyard. So here's me operating a drone. Not very good. But of course, even these double canopies can be pruned, very effectively by these machines. So you essentially have these pruning heads that have the rotary cutters and the what we call the sprawl cutters in the front. So the sprawl cutters, go in front of the machine. They get rid of whatever is, going into the rows. And the rotary cutters is what will, make the, final cut, and then define the bearing surface and the cutting surface here. So this machine is moving about 1 mile an hour, and these are half-mile rows. So he does, 2 rows in the given time. And, it would take us, 2 people per row to prune a row like this way. And since a management unit is 260 rows, you can imagine the labor force that was required to take care of these vineyards in the past. But these machines, move quite fast. There's a tractor driver, and there's an operator in the back that's operating both these pruning heads, and it moves quite good. And this does a very decent job, and people are quite happy with it. So the of course, after pruning, you have to go to a shoot thinning pass because you're retaining about 120% of the required positions that you would normally do with a hand pruning. So shoot thinning actually starts during dormant pruning because you're also removing shoots that would not go. Trunk suckering is also a form of shoot thinning. There's like suckers that grow along the trunk, but on the cordon, when the shoots are about 20 to 30 centimeters in shoot length, that's when we send the machine back in to do the shoot thinning. So in frost-prone areas, of course, people wait till all danger of frost has passed. What shoot thinning does, it reduces the shoot density, but impact on canopy densities are often temporary if irrigation is not managed. It's an efficient method of crop thinning. It will assist in the establishment of spur positions for the next season. And of course, it will reduce pruning in the next season. Our cost per acre, our cost is roughly around like $160 per hectare when we go with a machine. But if we bring in a crew, you're going to look at around like $350 to $360 an acre in this case. So it doubles more than that. So first, I'll show you how they do the trunk suckering in this case. So it's essentially these silicone fingers that go on the front of the machine, and then they will knock the unwanted shoots off. You can see that there's a gap, so it doesn't hit the irrigation hose and the emitters on there. So they can move about 2.5 to 3 miles an hour with this. So this is a fast practice. Otherwise, we would pay per vine, roughly about 40 cents per vine to get these removed by hand. So it can be quite a expensive proposition. So shoot thinning, this is a controversial topic. Most people will not do it because it reduces yield. But there are people that will do it. You need to consider a target shoot density. So when you're considering a target shoot density, you have to worry about count shoots versus non-count shoots. So there's a cordon brush, and then there are these rotary paddles. The actual shoot thinning is done with these rotary paddles in the front. So you can put 2 or 12 of these, depending on how many of these you want to remove on a given cordon. So tractor ground speed can be about 1 mile to 2 miles an hour in this case. So the cordon brush in the back, what it does, it gets rid of the hangers that might be growing on the underside of the cordon that cannot be, that can generate non-wanted shoots. So here's a shoot removal in the field. Let me turn off this thing. So here, this is a sprawling type of canopy, and as they're going through this vineyard, both the cordon brush and the rotary paddles are working. So this is what we would call a near premium vineyard in the central coast of California. And what they're doing is they're retaining about 7 shoots per foot of row. And that seems to be their like a sweet spot for the yields, et cetera, that they're wanting to hit. So of course, as I mentioned, you have to like match these with some sort of irrigation. When we did these trials about like 15 years ago, we compared hand pruned vineyards with 3 different types of irrigation regimes. So we did a sustained deficit irrigation, early deficit irrigation, or late deficit irrigation. What we found was, we could box prune these vineyards and then come back and shoot them to about 21 shoots per meter of row, and then do an early season deficit. That's when we optimize the yields. Of course, if you don't do any shoot thinning, you get a tremendous yield. However, you need to keep these vines producing. And that's usually managed by looking at the pruning weight per meter of row. If I do nothing, if I box prune them and just irrigate them like fully the whole season, you can see that I will devigorate them. The pruning weight per meter of row, declines very linearly. However, if I just change my irrigation to a early season deficit with crop load mid, I do, maintain the pruning weight per meter of row to roughly about like a 0.9 kilos per meter. So I'll show you another figure. This is 1 year, and this is the second year. So I make the same vine year after year. So you can make this, vineyard very sustainable with continued yield. Now, of course, I mentioned we optimized yields with crop load mid that 21 shoots per meter of row and early season deficit. This is where we also optimize our phenolics. This is with Syrah grapevines. People want like a deep, dark color with a good amount of tannins. And we have seen that reveal itself with a crop load mid with our early season deficit again. So we had the highest anthocyanins, tannins, and total phenolics in this case. Of course, there's all this talk about like, you only want to use a mechanized management if you're growing like, large amounts. Well, everyone wants to grow large amounts. Well, one question we got was, are you getting any herbaceous aromas from these grapevines or finished wine? So working with EJ Gallo, we did this trial. We measured herbaceous compounds and floral and fruity aroma compounds. So M2 here, the crop load mid with an early season deficit, gave us the least amount of herbaceous aromas, but also gave us the decent amount of fruit forward aromas in this case. And these are all degradation compounds from the carotenoid pathway. So as beta ion gets converted, you'll get the more fruit forward aromas in this case. Another not popular mechanical management thing is berry or cluster thinning. Two schools of thought. You can do pre-bloom thinning or post-fruit set thinning. You see the most beneficial responses if these are applied when berries are BB size, about 3 to 5 millimeters in size. And this is usually done running the harvester through the vineyard early in the season. So you'll set the harvester to about 100 RPMs, and then you'll pop off the a portion of the berries beforehand, and so you will reduce the crop load in this vineyard, hoping to get a physiological response. However, effect of cluster numbers or berries and fruit composition is quite controversial. So if you retain 1, 2, or greater than 2 clusters per shoot, you are not going to change the leaf area per length of shoot. You're not going to change the number of leaf layers before you see a cluster. You're not going to change the distance between shoots. What you're going to affect is, the berries are going to ripen earlier. However, this is not a really desired response from the winemaking side. So cluster thinning is done very sparing. Now, leaf removal is another practice that is done, very commonly. It can be done on both sides of the canopy or only on the morning side of the canopy. Because due to climate change, we're seeing a lot of dehydration if we don't do it on the afternoon side. Because if your rows are, let's say, north-south oriented, the sun will change around like noon, and the westerly side of the canopy is going to get exposed to this 40 degrees Celsius temperature for about 8 hours, and it doesn't cool off very quick. The cost of this can be about $160 to the hectare, so it's very cheap to do it with the tractor. But of course, if you do it by hand, you're going to double or quadruple the price. And lots of machines exist. Initially, the machines that came from Europe, they were suck and cut type of leaf removal implements. These were adapted to European conditions. They did not work for us. They also brought in these like air blast type of leaf removal implements, which would blow like air streams into the canopy to shred the leaves. However, we don't grow these like small vineyards like they do, so they did not work either. So we started working with these rollover type of leaf removal implements that are selective, meaning that they would not do damage to a flower cluster or the cluster. So you can use this anytime in the season. So here's a mechanical leaf removal. Let me turn off the sound so you can see it. So in this case, they're doing both sides of the canopy. There's my thumb because I'm an awesome videographer, as you know. Uh, so I removed the thing here so you can see it. So what this is doing is it's opening a 50 centimeter window in the fruiting zone of the canopy. And then as it's opening that 50 centimeter window, because grapevines are not native to the United States, and they're prone to all these fungal diseases that we have. This is to first of all warm up these canopy positions, as well as to improve spray deposition in these. So as it's removing the leaves, you'll see that the clusters are going to be quite visible. So you're removing about 20% of the leaf area, but you're removing the older leaves from this canopy. So the photosynthetic capacity of the vine is not diminished in this case. So for about like 6-7 years, I did quite a bit of work on this mechanical leaf removal and water deficits. You can do this at the pre-bloom stage. I mean, if you're growing mums, for example, Amy might know. I worked in Tennessee, in Springfield, Tennessee, at one thing grade in nurseries, South Central growers, and my job was to pinch the mums in August. But we devised a method to be able to do it mechanically back in the day. But you can do this pre-bloom or post flower or fruit set. So plant responds to these things differently. If you do the pre-bloom, you get a different response from the berry physiology, meaning that you can make more tannins, more skin flavonols, more anthocyanins. If you do the post-fruit set, you're going to decrease berry size because it's more exposed to sun, and it's going to dehydrate. But you also increase a lot of these desirable compounds. With water deficits, if you irrigate the same way, sustained deficit all season, you're going to increase berry mass compared to a regulated deficit irrigation, but that has a 25% yield penalty. So this gave a lot of options to people, like compare and contrast what they want to do, because it's real dollars. So when we took these vineyards, everything is pruned the same. You can do nothing, control, irrigate like grandpa did, and you're going to, the last two columns, total skin anthocyanins, grams per hectare, and how much it's going to cost you to make like these like desirable compounds to make like, good quality wine. You can do nothing from like grandpa did, and it's going to cost you $1.56 unit cost to make the phenolics. You can change, you know, just one practice. You can do a pre-bloom leaf removal. Pruning cost is the same. You're adding $30 to the hectare labor cost, irrigation applied, irrigation cost, etc. But your unit production cost of phenolics goes down by half. Because you're making more, almost double the anthocyanins compared to a control. Likewise, this rang true with a lot of the growers. So this practice was immediately adopted, and it's been very successful with our grape growers. Anyway, so there are lots of commercial applications that can come from this. The commercial application of this, we worked with a lot of people. We work with Oxbow quite a bit. They do work with the small fruit growers. what you need to move these into automation is some buy-in from equipment manufacturers. When you talk about specialty crops, there are a lot of specialty crops such as nursery crops. There's like berries, there's like grapes, there's like almonds, walnuts, all kinds of things. But when you put them all together, like acreage wise, they're still going to be smaller than corn and soybeans. So you might not be getting the attention of these equipment manufacturers. But working with these guys, we developed the selective harvest by a mechanical harvester. This was published in 2007. So what we did here was we mapped the water status of the vineyard, and it gave us two distinct zones. And within these zones, we continuously monitored the soil water by TDR sensors. And this map, holds true the whole season. And in this case, we were able to, load this map. You can probably see here next to Mike in the monitor. This harvester has two order conveyors. So we were able to pick one side to one gondola and the other side into the other gondola. So we were able to segregate the harvest. So the severe water stress region gave us the lower yield, but of course the worse quality because they did not photosynthesize enough, and weak water stress in this case on the green side gave us the better quality. So in terms of dollars, the red side was paid $720 a ton, but the green side got the full allotment of $2,560 a ton. So it went into a good program. So the growers are able to add value to their product in this case. But however, this was a homemade system, but a lot of the stuff that we used was, off the shelf stuff like Ag Leader Insight Monitor and the Ag Leader Liquid Product Control Module. These are the, fertilizer injection modules that they use in row crops. And the only thing that this did, so you either got a signal 0 or a signal 1 based on this, map. The conveyor either ran to a gondola 2 or to a gondola 1. So it was just like that. So it's a very simple system, but I don't know if anyone commercialized it yet because Oxbow just came back into the foray with this precision agriculture stuff. Anyways, I'll give you another example. This is a 25-hectare commercial vineyard. They gave it to us. They're like, figure it out. I'm like, all right. This was a Cabernet Sauvignon vineyard. When we looked at the soil types, it looks fairly uniform. However, there's a difference in elevation in this case. And then, of course, when you model the soil wetness in this case, it gives you a completely different soil wetness indicator. So the grapevine water status then follows this. And then as the season wears on, starting on the 14th of July here to October, you see that the vineyard starts separating into different zones. So you go to a high water stress and a lower water stress. You get two various different zones, and this water stress cluster gives you different, stem water potential. Different. I mean, everything is irrigated the same, by the way, and then gives you different stomal conductance, gives you different carbon assimilation, but based on that, you get different sugar accumulation and different organic acid degradation. Now, this was a very high cost vineyard. So, of course, once we presented this to the grower, they, marked this at $6,000 a ton, and this one at $1,700 a ton. So, water status and segregating a harvest in this case is a very good way to, add value to these vineyards. And of course, this was harvested in this manner using this system, and we were able to get the same results in a different wine composition. But look at in 2016, you get 215 units of anthocyanins versus 470 units of anthocyanins. So it's no surprise that this, 4 times the difference in anthocyanin accumulation gave you these price differences. Anyways, bottle price, it went to $11 to $26 in this case, wholesale. So the take-home message from these mechanization and automation things is, there's no silver bullet. Because vineyards, grape growing in the United States is very small. We're farming about 500,000 acres. So we're not getting a whole lot of attention from automation companies, except for a few, and they work very well with the growers. So there's lots of solutions, but not all treatments work at every vineyard because trellis types, etc., is not uniform. For red wine grapes, we found out that incorporation of early canopy growth control is key if you're going to mechanize these. And this is what builds up a flavonoid composition and retained in the later hot seasons, especially with those tall trellises, to burn up these green flavors that are not wanted by winemakers. In this case, that early season exposure by leaf removal is the only thing that works. To increase fruity, jammy flavors, if you're in this grape market, if you're using mechanization, you can do the late season exposure and water deficits, but this reduces yield and increases raising. And for white wine grapes, mechanization works great. And in this case, we just manage the crop load by just pruning a short bearing surface. So we don't manage the canopy, but we manage the irrigation in this case. So that's all I have for this. Hope I didn't take too much time, and I can answer some questions if you have any.
Thank
Dr.
you.
Kurtural, thank you. Go ahead, Amy.
I was just saying thank you.
Okay.
He might have left academia, but academia didn't leave him. That's interesting that you
Oh God, they still send me papers to review.
So I have a question. So you in vineyards you have lots of uniformity, and then you have this automation that sort of performs these tasks and reduces the labor. How quickly do growers sort of change their production practices to meet the requirements of the automation to make it effective, like in terms of raising heights, lowering heights, changing some of their other practices? How easily do they sort of move to adopt
I
to
mean,
meet both of them?
there's not a whole lot of uniformity in vineyards. There's quite a bit of uncertainty in vineyards. The trellises might be uniform. The non-uniformity comes from the soil texture. But vineyards is a very capital intensive business. So the last budget we did at UC, it was $53,000 an acre to remove and replant a vineyard if you own the land. So changes are very slow. However, you can convert a vineyard, and people have done that. But there has been a very recent push for replantings in vineyards, and all the new vineyards that went in this manner with the single high wire trellises. So that has worked quite well.
Excellent, thank you. If there's anyone else in attendance that would like to ask a question, you can unmute yourself and you can introduce yourself, and then also ask your question.
I
Give you a couple seconds,
have a question, if that's okay.
please.
I'm an engineer for a horticulture equipment company. We mainly focus on container growing farms. So I'm curious about how the stuff that you've learned carries over to container growers, or if you have any idea about that.
I don't know. I mean, when I worked in greenhouses, the automation we had was, stuff was like on a rack, and it was like going around, like getting irrigated, and like fertilizer was being put in. But that was a hanging. That was a big hanging basket warehouse. But I mean, as far as planting, transplanting, some of that work was semi-automated when I was working in greenhouses back in the day. Our work is super intensively managed by many people. So I mean, you'll have to talk with subject matter expert like Amy. So I don't know what practices are done in container nurseries anymore. So they would have a better idea, because I mean, engineers are great. They can make something out of nothing, but I don't know what to tell you. So Amy might have better ideas.
Yeah. Jeffrey, let me put my email in the chat, but just in the interest of time and it being a very specific question, let's connect offline and I'd be glad to talk with you. And I'm sure as would Anthony and the other horticulturalists in our group.
But Jeffrey, that's a good question. That's really what LEAP is about, because automation has not been as focused on nursery production as it has been on some other commodity crops. So really, that's what we're going to be doing in the next 5 years, is answering your question in a way that's both, economically feasible and saves on the amount of labor that you have to use.
Thank you. Thank you, guys.
There's a great question that came into me about this being recorded, and it will be available on the LEAP website, as I understand it. Kaan graciously gave permission for us to record that and have that available to you online.
All right.
Any other questions? I have a follow-up question but anyone ask a question. So sometimes when we talk about automation and then adopting it to reduce the reliance on labor. Oh, no, we got one in the chat. Do the silicone strips of the sucker removers score or scar the stems of the vines? That comes from Dominic from Greenleaf Nursery in the great state of North Carolina, by the way. Also,
no, they don't. I mean, like, by the way, the stuff we use is like all food grade, which is what sucks. It's it's super expensive. No, they don't score. So grapevines are ring porous, so the bark like sloghs off. So it doesn't matter if it like scores it a little bit. So it's not really a concern in our climate if they scored or do anything. So the idea is that they would hit the canopy at a good speed and revolution to be able to like knock these or pop these shoots off. But if they grow more than a foot, they're not going to take them off. So it's very time sensitive to be able to do these.
pretty dry in California, but with all of that, do you do any sanitization between cultivars of that
Yes.
suckering machine?
Yes, I mean, if you're like farming on the coast, whether it's like a Atlantic coast or like a Pacific coast, you have international trade, and since these industries are rural, you're prone to invasive species. I mean, look what happened to the citrus industry in Florida. So in between each vineyard, these machines are steam cleaned because of vine mealybug. So the vine mealybug came from Israel. Some guy liked a cultivar that he liked when he was visiting family in Israel, and brought a cutting to Temecula, California, and from there it spread within about 8 months. It's that's why we have to steam clean out all these machines, like both harvesters and other machines.
My follow-up question was, in some of our proposals and talking to people, they are very concerned about the reduction in the workforce when adoption of automation is increased. Have you had any pushback from any ag worker unions or the general public about reducing the reliance on labor. Now, nursery production, we need more workers. We're trying to replace the workers that aren't applying for the jobs. It's not like we're getting rid of workers. We're gonna keep the ones we've got. But have you had any pushback like that?
Initially there was pushback, but it's new. But once you start working with it, you realize that people don't want to work in 110-degree sun or a 95% humidity greenhouse. As they get trained with these machines, their income goes up. I mean, you get a better, more trained worker. We haven't really reduced our labor force because the same machines can harvest olives, berries, etc. Because this labor force would go from crop to crop. So and we couldn't get enough of these folks, but now you need more diesel mechanics, you need more hydraulic mechanics, you need people that can read or program a GPS unit or transfer maps. So it has improved a lot of people's livelihood. The pushback we're getting now is from the state legislature, because a lot of folks don't want to put a person on the tractor because it's a liability. So they want to be able to automatically automate the tractor driving. So the pushback we're getting is from the legislature. They're saying someone still has to be driving the machine. So that's the pushback we have from safety from OSHA point of view. Otherwise, I mean, these machines go, once you line them up with a row, they go.
That's very interesting. A slight follow-up to the automation question from Arden Pontash from Pennsylvania. Are there specific computer software programs that you work with to control the automation? I suspect that might come with the engineers themselves, the graphic user interface, and how easy is that to use by the workers? Like, how easy is it to interface with the software that controls the piece of automation?
If you're using ag equipment, I mean, those are going to be very grower friendly. But the other stuff that we have used in the past, we worked with Carnegie Mellon in the past. They had a lot of software, but I had to hire a different postdoc just to even operate the program. But I don't think those things are quite ready for grower implementation. But ag leader software, etc. These are straightforward programs.
Carnegie Mellon has always been on the cutting edge. That's why they're on LEAP.
Ag leader has been around
on the
for
call.
32 years, so it's pretty foolproof in my opinion.
Excellent. Any other questions before I let you all go? Or not the LEAP members, but all the other guests today. You're not getting out of the other hour of our meeting.
Yeah. I'm out.
I really appreciate you all attending today. In April 17th at our next meeting, the guest speaker is going to be Nicole Gaspaldi from Womack Automation in Italy. He's going to talk about automation for nursery production they use there. So I'll send you all an email for that. So thank you very much, Dr. Kurtural. We really appreciate your time and efforts. And thank you for joining us today.
Yep.